Hi, I'm Griffin, and for my internship, I made a cold hardiness prediction interface. So first about me. My name is Griffin Riley. I'm from the Portland area. I am a recent graduate from Oregon State Cascades with a degree in computer science. I'm currently an Agate intern, partnered with Alan Fern and Kristen Goebel. So to start off, let's talk about frost mitigation. In the Pacific Northwest, weather can often be uncertain, especially with cold snaps during the winter. At low temperatures, these cold snaps can kill off dormant crops, causing massive losses. There are countermeasures to deal with cold snaps, but they are very expensive, so it's important that they get deployed at the right time. However, to help with all of this, we have cold hardiness, which is the inherent resistance crops have to cold that varies throughout the year. Cold hardiness is measured using LTE, or low temperature exotherm. To sum it up, LTE-X is the temperature at which X% of crops die. Cold hardiness is strongest during the winter, and then gets weaker again during spring as crops reacclimate to warmer temperatures. Predicting LTE can allow deployment of countermeasures intelligently. However, predicting cold hardiness is a very complicated task. Previous cold hardiness models were constructed by scientists manually. These models were pretty simple and only used the temperature of the current day as input. Agate researchers theorized that they could outperform these traditional models using neural networks. The biggest advantage of these neural networks would be that they could use all the weather data as input, rather than just the temperature for the current day. They then created several neural network models, each of which predicted LTE 50 for grape cultivars. These models each used entire seasons of weather data as input, with the temperature, precipitation, and so on for every day in the year. They wrote a paper on this, so if you're interested and want more information, the link is shown here. However, the issue with these models that they created is that they still need to be tested by scientists to make sure the results are reasonable and that there's no input values which break the model. However, the models lacked a way to interact with them, and at that point they were just code that you had to run, which wasn't accessible for people who weren't already programmers. I was tasked with creating an interface for these models, a way for non-technical people to interact with them and test various inputs and outputs. To build this interface, we chose to use Excel. We chose Excel for a couple of reasons. First of all, most people, especially scientists, would already know how to use Excel, which makes teaching people to use the model a lot easier. Also, manipulating data, which is something that people will want to do a lot of when using this model, are very easy to do using Excel. This interface that we've constructed allows users to manipulate the input data, which model to use, which cultivar, aka which strain of grapes to predict for, and the output metric, aka LTE 10, 50, or 90. And now, let's go to the interface. Here we go. This is the main page of the interface. There are also several other pages, an instructions page, and a bunch of data pages. More on the data pages later. Now if we go back to the main page, it's broken up into several sections. Over here, we have the space where the predicted output actually goes in raw number form. That data then gets graphed here. We also have a bunch of settings here, in this area. Right now, the settings are output column A, so the output data will go here. Use the 2021 to 2022 weather data as input. Use the MTL model to make predictions. Use predict using Concord for Concord grapes. And have the output metric be LTE 50. If I then press make prediction, wait a few seconds, numbers are going to get spit out over here, and then graphed here. So, however, let's look at another use. What if you want to modify the data? It has this as the input sheet, so the data is coming from here, this sheet. This has the date, and then a bunch of weather data for an entire year. If I modified this data, it would affect the output of the network. I actually already have this modified data sheet, which I applied some transformations to the data using Excel's data tools. If I go to the main, change the output column to B, and tell it to use this modified data input sheet, and then press make prediction. The output column is set to B, so the data will show up here, and then it gets graphed alongside the previous data, and you can see that the beginning and end are the same, but in the middle of winter, this modified data has significantly higher LTE, so less frost resistance. Another possible use is, instead of doing the modified data, you could change which model is being used. If instead I wanted to try the additive embedding model, I could change that to add embed, keep this on column B, and press predict. It's going to overwrite this data with new data. Now, these two data are two different models trying to predict the same thing using the same data. And as you can see, the results are quite different. So clearly the models are not all the same, which just goes to show why they need fine-tuning. Now, if you can press this button to clear all predictions, and that is how the interface works. So, overall, my interface can be used by scientists in order to fine-tune and perfect all of these models. Once this is done, these models will be then distributed to growers who can use them to predict cold hardiness, and in conjunction with weather data, they will know when to deploy cold snap countermeasures, which will save a lot of money and result in more crops produced. There are several possible directions for future work for this project. First of all, adding support for cherries. Right now, this model only supports grapes, but this interface only supports grapes, but there are models for cherries that have been trained. One possible future work would be adding support for these cherry models to my interface. Next of all, the filling of missing weather data. There is some holes in the weather data that we have, and this would involve basically predicting what goes in those holes. Finally, the final piece of future work is, of course, the goal of this project, overall distributing this model to growers. This would possibly be done with this interface, or possibly with a different interface. This, if completed, would result in the completion of this project and, ideally, huge savings and more crops produced as this model gets put into use. Thank you for watching.